Hi everyone. In today's lesson, we'll be taking a look at the most basic tangent function. So in your notebook, please put down today's subtitle, Basic Tangent Function. The basic tangent function has the most basic format of y equals tangent of x, where x tends to be in radians. However, nothing stops us from analyzing this function in degrees either. In order to best illustrate how the basic tangent function looks like, we'll use a table of values. Please take a moment, pause the video, and prepare the following table of values with the given independent variables. Go ahead, do it now. With your table of values ready to go, and your calculator in your hands, let's take a look at what the tangent of some of these independent variables will give. When x is 0 radians, tan of 0 radians will give 0. When x is pi over 3, the calculator should give you a value of approximately root 3. When x is pi over 4, the y value is 1. When x is pi over 2, this is interesting, the calculator should produce an error, which means that when x is pi over 2 radians, the tangent of x does not exist. Next, moving on. When x is 2 pi over 3, the y value will be negative root 3. When x is 3 pi over 4, the y value is negative 1. When x is 5 pi over 6, the y value will be approximately negative root 3 over 3. And finally, when the x value is pi, the y value will be 0. In order to accommodate our graph, we're going to be needing a Cartesian plane that's about this size and calibrated in this manner. Please take a moment and pause the video and carefully prepare your Cartesian plane. With your Cartesian plane ready to go, let's draw this graph. The first thing I'd like to deal with is what happens when x is equal to pi over 2 radians. We see from the table of values that the tangent of pi over 2 radians has no y value. This in fact represents a vertical asymptote. Let's indicate this asymptote at pi over 2 radians by drawing a red vertical line. Believe it or not, there are other asymptotes that exist. If you take your calculator and try to punch in the tangent of negative pi over 2 radians, you will find out that there also exists an asymptote at that location. So let's put that down with another vertical red line. Take your calculator one more time and try punching in the tangent of 3 pi over 2 radians. You will find out that your calculator gives another error. That means when x is 3 pi over 2 radians, there exists another vertical asymptote. So let's show that with another vertical red line. Next, let's start getting down some of our coordinates. Starting at x equals 0, we have y equals 0. When x equals pi over 3, the y value is root 3, which is approximately 1.7. So right about there. Next, when x is pi over 4, the y value is 1. Next, when x is 2 pi over 3, the y value is negative root 3, which is approximately negative 1.7. So that'll put it right about there. Next, when x is 3 pi over 4, the y value is negative 1. So that'll put it right there. Next, when the x value is 5 pi over 6, the y value is negative root 3 over 3, which will put it at approximately a little bit less than 1. And finally, when the x value is pi, the y value goes back up to 0. If you continue punching in different x values between pi over 2 and 3 pi over 2 radians, you will see that your coordinates eventually form a shape that looks like that. In a similar manner, if you were to continue punching in x values between negative pi over 2 and positive pi over 2 radians, you will see that the coordinates form a shape that looks like that. And this is essentially the shape that a basic tangent function has. It is essentially a bunch of S waves located between a series of asymptotes, and each repetition of the S wave has a period of pi radians. Within each S wave, there is a point at which the wave switches curviness. To be specific, it switches from being concave to convex, or vice versa. This point is what we call the inflection point. And that's all there is, ladies and gentlemen, to the basic tangent function.